All right, everyone. Very good morning to all. Good evening for some countries. All right. Let me start sharing my screen, then we can start the class. Okay, so hope my screen is visible, right? Everyone?
Yes,
Is
sir.
it okay? Thanks, Amrita. Hi, Arpita. Good morning. Battalion, good morning. Dinesh, good morning. Himani, Ravi, everyone, good morning to all.
Good morning, sir.
Good morning, ma'am. All right. So we are going to start this CCNP. So before I start, any questions anyone have in your mind? Because I'm going to start today first module. Last week there was some disconnection on the my side. I was not able to take full of the sessions, but yes, we are going to start with the very first module. But before I start, if you guys have any question, any doubt, please feel free to ask. So I'll just take that questions and then we'll proceed with the modules. Okay, so I believe everyone is happy. No questions. Please feel free to ask. Even you can put in chat if you have any questions. Put in chat. I will try to take those questions as well. Never hesitate. If you have any doubt, not able to understand anything, feel free to always ask. Okay, so the first module we are going to start, that is the CCNP ENCOR. Okay, and this ENCOR is going to align with the new syllabus. That is the version 1.2. Earlier, the syllabus was version 1.1. This has been retired. The last test of this particular version is 18th of March. So just we have 11 more days. So if someone is planning to give the exam as per the old module, they can plan, but I would not recommend you guys to plan for this one because still we require at least 2 months and more than that to finish this session. So technically we are going to cover everything version 1.2 exam. And this exam is going to cover a lot of new topics which was earlier not available in the version 1.1. So I'm going to be completely aligned with this. So there is, like you can see, first day to test March means first date to test March 19 2026 means the first exam for this 35401 in core version 1.2 exam is going to be happen on 19th of March. So after this session, you guys can plan for the exam. I will also guide how you can plan for the exams if you have a plan to do the exam as well. So we are going to cover everything as per the modules. Means I'll go sequentially. Like first we'll discuss the architectures, then we're going to discuss about the virtualizations. So the questions from the exam you're going to get from the architecture is a 15%, virtualization 10%, and majority of the question 30% is going for the infrastructures. In infrastructure, we are going to do a lot of deep dive regarding the most of the switching concept. You can see 802.1q trunking protocol, ether channel, RSTP, HTTP, MSTP, BPTU guard, root guard, port fast, like that. We are going to cover. And then we are going to understand the concept of the routing, EIGRP, OSPF, right, BGP, like that, and policy-based routing we have to understand. And deep dive we are going to do that in the CCNP NRC. Means if you want to become a champion of the complete routing, you're going to get the basic fundamental of the routing, but the deep dive is going to happen in the CCNP NRC. So we'll cover later on. But definitely we are going to do some practice here as well. And also you're going to be champion for the NAT PAT and VRRP, HSRP, multicast concept. These all are going to be part of the infrastructure. So infrastructure is quite high weightage. That is 30%. And then we have the network assurance. It's more about the troubleshooting. Like you have to understand how to monitor the network, how to configure the SNMP, sorry, not SNMP, span, RS span, ERS span, IPSLA, net conf, rest conf, and also SNMP troubleshooting, trace routing, everything is going to be there. Syslog configuration. And then also we have the security. CCNP also have a security where we have to understand about the ACL, scope policy, REST API, AAA authentication, line VTY. And also we have to understand about the next generation firewall feature. What is the endpoint security? What is the threat defense available? What is the next generation firewall? What is the trust sec? What is the max sec? And then we have to cover the automation and artificial intelligence. So this is the quite important for the everyone. So let me repeat again for the new people. Nowadays, the requirement of the market, every network or security engineer have some idea about the AI and the automations. If you don't have this idea, so probably you are going to be stuck in your future. Even you are the network engineer, right? You should have these skills. Even you are the security engineer, that also should have this skill. So any NetSec engineer is planning to have a good career in the future. They want to have the good knowledge for the networking security. They must have to understand the automation and AI as well. So we'll see how the Python is going to be configured, how we can do the configurations while using the Python for any router switches. What is JSONs, means Java script object notation language, how machine is going to understand machine learning language, XML, JSON like language, Yang data modeling, right? Also, we understand the Cisco Catalyst, DNS Center, and the SD-WAN Manager API, and also we'll understand the REST conf and netconf, EMS scripting, and also we'll understand the orchestration tool. So these all are going to be covered in the automation. So I just given the briefly. So entire syllabus is going to be aligned as per the actual modules of the CCNP that has been provided by the Cisco. Okay, so what is the first thing going to start? That is a architecture. All right, we'll do intro later, no problem. We have a lot of time, so we'll do intro, but let's focus today on the study. We'll see the intro part also later on, so you guys understand each other, who is doing what and where they are staying, which company we're working, and what are the expectations. So probably tomorrow, if we'll get time, 5-10 minutes, we'll do the introduction as well. But let's focus on the architecture first. So very first module, guys, architecture. Why architecture is important? Why architecture is important? Architecture is important because you must, being a network engineer, being a network security engineer, you must know how my network should be look like. Means if you are trying to build any network and you want to just design any network, so your architecture must be there. Means your network should be high performing. Means you have to make sure your network should be high performance. Your network should be secure, right? Your network should be reliable, right? They have the HA, means high availability. They can easily, right? Easy to manage, easy to troubleshoot. So also it should be like scalable, means if you want to expand the network for some kind of the requirement, so your network should be also scalable. So these all parameters, let me see why. Okay, I think it's going to be upper side, so I don't know. So your high performing network should be there. That should be secure, that should be reliable, that should be the high available, right? Easy to manage, easy to troubleshoot, and scalable. Means if you want to expand your network, right, it can be easily able to expand. It's not like, yeah, there is limitations, we cannot do any kind of modifications. Like, think about it in this way. You're building one of the building, right? Means you're trying to build one of the house, and you just design a floor plan for the first and second. Means you just make a two floors. There is a first floor and there is a second floor. The builder who does just design this all floor, first floor and second floor, they never consider you are going to be do future expansion for the third floor and fourth floor as well, right? Fourth as well. So what is going to happen? The pillars are going to be like designed according to second floor and first floor, like weight, or you can just see dimension and everything. The moment you are going to be start adding the additional floor, this might pillar is not going to be take that much load or not able to sustain. Builder is not going to be stay very long period of time. So whenever you're going to design any house, you make sure what is your future plan. If your future plan is, I want to make 10-story building, 5-story building, but initially I'm going to just deploy 2-story. So your foundation should be designed in such a way, even in future, you want to expand the building, it should be able to take the load. So your network should be scalable, that easily can be expandable. So similar way, if I'm going to design any kind of network, it makes sure that can be easily cater the future requirement. Think in this way. Let's suppose this is my company, and company having a 500 people, right, in office. Let's suppose this is a office campus. They newly built the office campus, but office campus having a total 5,000 capacity. Means 5,000 engineer can sit in the office campus. But currently they have the 500. But company having their strategy, their expansion growth also in the future. But initially the network designer, network architect, designer, whatever you can think about, they buy the very low end routers. Let's suppose they buy the very old router 1921 that has been end of life. But think about, they just buy the 1921 router. That's very low end router, or might be the 881 router. That's also have been end of life. Very small router they buy. They spend the money, but these routers right now able to carry the traffic of the 500 user. But the moment this has been expanded to 5,000 users, these routers are going to be useless. So again, you have to send in the, uh, you just have to remove from your router link, or might be the connectivity or rack, and you just have to put in the spare part, and you have to buy the new router, might be the ASR 1001 router, ISR router, like that 4000 series router. So again, you have to buy the money. Means again, you have to spend the money, and then you have to buy the router. So why not initially, when you have the plan to deploy the router, you must have to make sure the router I'm going to use, that router is even expendable. It can be used in the future as well. So those kind of the things also you have to take care. Similarly, if you're deploying any firewalls also. So the firewall you are going to deploy, make sure the firewall having the future expansions. Not go for the small firewall like 220 Palo Alto firewalls, or might be the 40 gate firewall 40 if you are going to deploy. So these are the small range of the firewall. But if you have the future expansion, you want to get the high processing capacity, you want to get the high processing traffic, then you might be initially you have to go and deploy the 820 firewall, or might be you go for the 450 firewalls, or even the 5,000 series of firewalls. If you have the future expansion on 1410 firewall also, you can deploy that. So any hardware, any kind of the link, bandwidth, any infrastructure you're designing, you must have to make sure they are very much scalable. That is the very first thing. They are very much reliable. It's not like I buy the hardware and it's not reliable. It's always going to be creating a problem. It should be secure also, right? It's going to be high performing also, and it's going to be easy to manage. This kind of things you always have to take care of your mind. And that's why architecture come in a picture, right? You know who is getting high salary in the market right now? Who is getting high salary in the market? The engineer who are the network architect, right? Network architect. The security architect means any architect level of job, means you are the L2 engineer, you are the L3 engineer, but you are in the operations, just doing the troubleshooting, implementations. Your salary in compared to the network architect is always going to be lower side. These people are always going to get a higher salary. Why? Because they know how to design the network. They know how to troubleshoot the network. They know how to implement the network. So they have the troubleshooting skills. They have the implementation skills. Plus, they also have the design skills. So everything they have. So the person who have that much skills, definitely they're going to get easily 40 plus LPA in India in INR, or even the 50 plus LPA as well. They can easily going to get that if you have the good experience, and you are in the India, and you are just preparing for the high paid job, then you can easily get that kind of jobs, right? So let's understand how network architecture is going to look like, and what is the step-by-step plan. Any questions, any feedback till here, guys? Or we are good till here? All good, Amrita, Arpita, Dinesh, everything is good till here?
Yes, sir.
Yes, sir.
Understand why architecture is very important. Okay, so now let me explain. it's more about the theoretical parts. There is no practical in this first module. We just have to understand the most of the concept. So you can become a good designer, good architect for your network. CCNP ENCOR is going to give a platform where you are going to understand about the architect. Means you are going to understand the architecture of the network. Why LAN is designed in such way. Why WAN is designed in such way, and why SD-WAN is going to design in such way, and why my Catalyst DNS center is going to design in such way. What is the high availability? What is the SSO? Everything we're going to discuss about. So let's first understand the design principle use the enterprise network. We are talking about the enterprise network. What is the enterprise network? Anyone know? If someone is going to ask, what is the enterprise network? No idea? What is a home network?
So home network is kind of Soho network.
Yeah. So,
Means it,
okay. Home network is so.
the
So full form is small
office home net.
office, home office, right? Kind of that, right?
Yes, sir. Yes, sir.
So Soho is basically a small office, home office kind of network, right? So that is the home network. And what is the ISP network?
ASP network is kind of which provides us the connectivity, which give the facility of broadband to connect our different offices or to create
Hmm.
the VPN tunnel. Means we have to purchase the subscription.
Very good, Arpita. Okay. So guys, everyone have to be participate. So I at least understand. So we are trying to understand. We have the three type of network across the globe. The very first thing, everyone in your house using the home network. Might be working from home, right? Even you're not working from home, you're just using the internet connectivity for your any kind of the internet browsing, TV, watching the Hotstar, watching the cricket match, watching any kind of the Netflix show, Amazon Prime show. So anything within your home, let me use the different dashboard. I can explain here better way. This whiteboard. So in home network, let's first about the home network. I'm talking about the home network. What is a home network? So home network generally, this is your home. Home having generally one of the router is going to be there. That is a router. This router is just broadcasting the signals. Okay. Via the Wi-Fi. We all agree this router is known as the Wi-Fi router. And I hope everyone is doing this class with the Wi-Fi router only. This Wi-Fi router is just spreading the signals across your home, right? Every corner of your home. And you might be sitting in your bedroom or your study room. Yeah, your laptop is connected with his home. This kind of the connection is known as the WLAN, wireless LAN. So how wireless LAN is connected? Because this PC have the wireless NIC card. NIC is network interface card. If you want to connect with a wired, there is a wired NIC card also available. Wired NIC card also available. So PC coming nowadays, most PC are coming the wireless. There are very less PC coming in the wired. But even you want to purchase the wired LAN card also, it's available. You can connect the direct cable and it is going to build your network. So your ISP router, that is a Wi-Fi router, is spreading the Wi-Fi signal. Based on that, you connecting this PC. And similarly, your home having the multiple devices. Might be you using the printer also. This printer is going to be there. You might be using some TV as well. So TV also going to be connected to the same routers. You might be your mother, father, your sister are using the phones as well. So phone is also going to be there. You having any desktop, it's also going to be connected there. So might be you having 10 to 20 devices which need to be connected and this going to be talk internally without any issue. If they have to do the communication within the LAN network. This area is known as the LAN network. So they can easily communicate with the LAN, means every signals are going to be communicate via this within the home by using the Wi-Fi. But the moment they want to communicate with the WAN, so they need the ISP. This router is going to terminate the internet link, and that is known as the WAN circuit. It could be your copper or could be your fiber. This is going to connect with the ISP. This ISP could be your Airtel, could be your Jio provider, some other local provider also can be there. And then this is going to connect with the internet. So home network is the small network. Inside of the home network, we have the 10 to 20 devices, and that much devices can be catered by the small router, which having a responsibility to make sure they have the connectivity with the internet and ISP. That's simple, right? So very small network, any SOHO network, what Arpita told, any SOHO network, basically small office, home office network, generally require 10 to 20 devices. And these devices can be catered by the Wi-Fi routers and they can connect to the internet. So you can always going to connect to the internet. But when I talk to the enterprise network, let me draw here enterprise network. Enterprise network, that means you have the very big company. Okay. This big company might be sitting 1000 to 5000 users. Think about it. Does this home network able to cater that much traffic? The answer is no. These routers are designed in such way who can just carry the small amount of the traffic, who can serve the small number of client within the any location. It could be their home, it could be their office. But the moment you're talking about the SCL, moment you're talking about the Wipro, how many routers are going to install? It's impossible to install. Means SCL campus, you see almost 10 building within the one campus, and every building having a thousands of users or 2000 users sitting that. So you end with the installing the routers, these Wi-Fi routers. It's going to be very costly again for you. It's very hard to manage. It's very hard to troubleshoot and hard to scale the network. So to mitigate this problem, enterprise network going to use the different model of routers. They use the routers, might be two routers. Why two router? We'll discuss about that. But I'm designing two routers. These routers are not similar to the Wi-Fi router. Let me show you. If I talk about the Wi-Fi router, your home routers, these routers are going to be like this way. They are the home routers. You can see they are spreading the signals, and based on that signal, you're connecting to the multiple devices. But if you talk about the enterprise router, or might be, let me type Cisco routers. These routers are quite bigger. You can see these routers are like this one. They have the more power, more kind of the RAM, more kind of the processing, more kind of the high bandwidth. So you can see these are the 1 GPS router. So they are the bigger routers. Cisco, if you check the Cisco routers, like ASR and ISR, see, they are the even bigger routers available. So these routers are having a capacity to carry high amount of the bandwidth, even the Gbps, more than 10 Gbps, even 100 Gbps. Some routers even support the TVPS as well. You just have to use in data center and the very high Azure AWS kind of the deployment. So those kind of the bandwidth also available. So enterprise networks are quite large network. Means where we have the 1000, 5000, 10,000, even more than that users are sitting. And inside of the LAN, if you talk about the LAN, not only having the phone, printers like TV, no, they having a servers, multiple servers they having. They having the CCTV, okay? They having also printers. They having thousands of laptops, right? They have the WLC. They have the firewalls. They have the load balancers, LB. They have some kind of the what else? Access point. They have the IoT devices. Okay. They have the CCTV. Means we have lot of devices. They have the switch also, which need to be connected. So enterprise network have the variety of devices, like we have the servers, we have the CCTV, we have the IoT, we have the printers, laptop, WLC, firewall, LB, access point switches. Those devices need to be connected together to serve this kind of the user. And further, we have the very high bandwidth link, which is going to connect with the ISP-A, and another router is going to be connected with the ISP-B. This is going to be ISP-B. So why there is two ISP? In case of the one link is going to be down, another is going to be make the services up and working. So ISP network is the big network. So if you're going to compare, if you go and compare on Google as well, difference between Soho versus enterprise network, you're going to find some key difference. See, Soho, a small office, home office. Network designed for the 1 to 10 user. Even I talk about 10 to 20 users because we can use that. There's no problem. With a simple, often in the one hardware, focusing on the cost effective, e.g. plug and play setup. When simple, you just have to deploy one of the router. Based on that deployment, you can just simply plug the cables for the WAN side, and it is just spreading signals in the LAN side. You can connect the devices and you are good with that. Enterprise network. See, enterprise network served hundred to thousands of users across multiple locations. Means if you have the multiple offices, multiple buildings, like I given the example for SCLs. If I have the multiple users, multiple building, if I want to serve them, these networks are not enough for me. These are going to be totally unscalable network. So if I want to serve, I need to use the enterprise network, who is going to serve thousands of users, hundred of users for the multiple location, and also required high performing hardware, which is a specialized hardware as a core router, managed switch, robust security like firewall, dedicated IT management. Okay, so scale and means you can see the difference between Soho means small. You want to use hardware, it's very simple. But if you're going to talk about the table wise, 1 to 10, 100 to 1000, it's integrated consumer grade routers are going to be required. Like we have the simple any Wi-Fi routers available. It's a specialized in the any kind of the hardware like Juniper router, Cisco router going to there. Simple setup is going to be there. It's a very high complex configuration is going to be there. The cost is going to be low for Soho network. This enterprise cost is going to be very high. Redundancy, no, but it's a high available. That's why I draw the redundancy as well. So you guys can just compare, right? User can manage, but dedicated IT personnel. So you are going to be engineer for the this enterprise network, not for the SO network. So the learning we are doing for CCNA, CCNP, CCI, these all are designed to become a network engineer to manage your enterprise network, okay, or ISP network. Now, what is the ISP network? We understand about the home network. We understand about the enterprise network. Now let's focus on the, shall I clear this? Any doubt here? Anyone have? Any questions? Any feedback? Anything? Anyone?
All good, sir.
All good? You guys able to understand what I'm trying to convey the point?
Yes, sir.
Yes, sir.
Okay. So now let's explore what is the ISP network. Except Arpita, anyone want to say anything? Amrita, Battalion, Dinesh, Emani, Sony. Any point, guys? What is ISP network?
Connection between multiple internet service provider and connect with different AS number and maybe establish a connection between multiple locations, countries, continents like that.
Right. That's correct. ISP is basically known as the Internet Service Provider. Okay. Internet Service Provider. Why you use? So let's take an example. My one enterprise office in the Delhi. Okay. Another enterprise office in the USA. Another is my in the Singapore, right? Dubai also I have. Now these are the all enterprise offices. Means every office I have the thousands of users. They want to communicate. How they are going to communicate? They required a connection because Delhi is in India, USA is different country, Singapore in different country, Dubai in different country. They want to communicate, then they require the infrastructure. There is two methods. They can communicate via air or via cable. Only two methods is available. But air is not possible for that much long distance. You can do the communication over air. That's absolutely fine. We are doing the any home-based communication with a router. That is the air-based communication. Even for you have seen the guys, these antennas. Let me show you. Microwave antennas. You have seen this kind of the antenna. You have seen the towers where the antenna is installed. Might be nearby. You go and check that. You might be have this kind of the towers available in your area, and this kind of the antenna is going to be configured. These antenna can send the signal up to 5 kilometer, 10 kilometer, 20 kilometer. They have the different range, right? The big side of the antenna you are going to use. This is known as the outdoor unit. They can send any magnetic signals from one location to another location. It's easily to send that, but it cannot send the signals even for the Delhi to USA or Singapore. It's a very long distance of the locations. So what option we have? We cannot send via the air. Air is not possible to just send the signal. So only possible we have another method is that is known as the cable. Now cable, we have the two cables. One is the copper cable and another is a fiber cable. Can I connect with the copper cables? These two locations? What do you guys think?
Not possible.
No.
We need a fiber cable and especially for submarine cables.
Yes. So copper cable is also not possible to cater that much distance. So we can remove this copper. Copper is also not possible. So only we have the option is a fiber with the help of the submarine cables. So we have to use the network by the help of that network, which is just built based on a fiber ring, fiber connectivity. So we can connect this location. But this is also not possible. In India, let's suppose I have the Airtel link available here. Let's suppose Airtel link is available here. Airtel alone is not possible to have a fiber till Singapore, till USA. No. They have the different ISP. Submarine is going to be there. Definitely. Means submarine cables are going to be there. Every location they want to communicate, the submarine cable are going to be there. Based on that submarine cables, multiple ISP is going to be connected. ISP might be the Verizon is going to be there, might be the AT&T is going to be there. Then you're going to make the connectivity with these locations. So the network who is going to extend your connectivity from one ISP to another ISP, that is known as the ISP network. The network who is going to extend the connectivity might be the same ISP from one location to another location, that is known as the ISP network. Means if you want to see the ISP network diagram, see, These are the ISP network. You can see they are having the backbone. Means lot of connectivity, lot of area, lot of geography they are going to cover, and based on that they are going to make the connectivity. So if you just going to compare, let me go here. Difference between enterprise network versus ISP network, you are going to get some idea. So see, enterprise network, we know that private secure infrastructure that is going to be dedicated for the multiple users, multiple device can connect it. But if you want to ISP network, that is your external network, high scale connectivity, where multiple ISP is going to be there connected. Public, multiple clients, highly multi vendors, because you require the multiple ISP to carry the your packet from one location to another locations. And if you just want to go on the community also, you're going to find some good articles if you really want to learn about that. But the concept is going to remain same, what I just explained. See, enterprise network deal means customer, hospital, hotel, point to sales, government entity, means any banking sector, HDFC, SBI, any ministry, hospital, that is going to be your. While ISP network is about the IP transmission technology, cloud, multi-tenant, MPLS linking and all. So ISP network is something where you have to make the connections from the multiple locations, multiple building by using the internet connectivity, or might be the MPLS connectivity, that is known as your ISP network. So I hope we understand at least fundamental of the network type. And only three type of network. Data center network also going to be there. So if there's someone is going to what is data center network, so data center network is all about you building your own private data center. And in this private, it's kind of the enterprise network. Data center also known as the enterprise network, where multiple server are going to be there. All different server is going to be for HR, for Citrix, for IT, for sales, for portal. And they have the high processing switches, high processing router, high processing servers, high speed backbone connectivity, back uplink, downlink connectivity, which is going to make the connectivity to the servers. So these are known as basically DC network. So that's not our target. We are not targeting DC, but somebody is asking, then you can just think about it's again ISP network only. And based on that, we can make the connectivity. Okay, now coming back to the topic again, means we have the understanding about the enterprise network, home network and all. Now we have to understand high level enterprise network design, such as the tier 2 network, tier 3 network, fabric and cloud. So let's understand one by one, what is the tier 2 network, what is the tier 3 network, and what is the fabric, and what is the cloud. We'll understand one by one. So very first thing, I will share this ebook as well. And this ebook, if you go here and go in the chapter 7, there is we have the architecture. In this architecture, everything what I'm going to explain is 100% going to align with this ebook concept, because I just use this book as a reference. And even I do the study for this book, it's a very good book. It's not only for the CCNP. This book is designed for the CCI as well. So if you're planning for the CCI exam, CCNP is ENCOR is going to be act as a CCNP, CCI written exam. So you want to crack your CCI exam lab, you must have to crack your written exam by referring this book. This book is prerequisite to pass the CCI. Your written exam is going to align from this book only. So that's why this book is very important. And that's why you can see CCNP and CCI Enterprise Core ENCOR 350-401 book. So it's a good to have this book with you all. I will share this book definitely and try to learn everything from this book. Now, moving back to the network architecture. In this architecture, we are going to cover how the LAN design is going to happen and how my enterprise network architecture is going to happen. Means both things we are going to do the deep dive, because we are targeting about the enterprise network. There are some questions answer also. If you guys want to do the practice, you can do the practice, but we'll do later on. But let's start doing the understanding. So anytime, whenever going to understand the LAN design, there is two component we have to design for the enterprise network. Any offices, if you want to build any network, there is two component is going to happen. One is going to be your LAN and another is going to be your WAN. So you should, being a network engineer, you should know how to design LAN. And similarly, how to design WAN. You should know both of the things. If you don't know how to design LAN, how to design WAN, you probably not going to become a very good engineer. Similarly, if you want to become a firewall engineer, so you also know how to design how to integrate the firewalls in the LAN infrastructure, F5 in the LAN infrastructure, how to make the connectivity with the cloud connectivity with the gscaler, Prisma Access, SASE, and everything. So that is a different thing, but you should know. Take an example. I hired as a network engineer, okay? And my company is known as the ABC company. And let's suppose I hire the Hemai. I told you, hey Hemai, I have an office, good office, and this office have total thousands users sitting in the office. Can you tell me how these 1,000 users are going to communicate with my internal server, which are going to be hosted in this particular locations, S2 and S3, and other different devices, printer, like they have to access the IoT devices, door access like that. So what is the all LAN infrastructure needed so I can cater these all kind of the users? Might be you can cover the LAN based on the wired connection or WLAN that is going to be wireless. So if you don't have any kind of the idea how my LAN is going to design, where my user are going to be connected, where my server is going to be connected, how they're going to communicate, which protocol is going to run, probably you're not able to answer. But if MI have the any idea, means how the standard architecture is going to look like. If you have done the study, how we can design the very cost effective and reliable and a scalable network, then he can guide you. So that's why we have to understand how we can design. And here you can see, whenever you have to go and start design things, you have to understand in LAN design, there is a three layer. One is the access layer. You can see here. Another is a distribution layer, access layer, and the core layer. So we have to understand what is the core layer, what is the distribution layer, and what is the access layer. Also, you are going to get a design type. There is the two-tier architecture and three-tier architecture. You can see this is known as the two-tier architecture. This is known as the three-tier architecture. So which scenario I should opt this two-tier architecture and which scenario I should opt this three-tier architecture. That also we have to understand. So we'll do the deep dive one by one. You can see they are talking the different layers, and then also they are talking about the two-tier architecture. It's known as the collapse core architecture. And if I go down, you're going to get the three-tier design as well. And the same thing, if you go here, here you see here, they are talking about to understand the two-tier and three-tier. Then we have to move in the fabric. So let's start. What is the access layer? Anyone know what is the access layer?
Yeah,
Any
so
idea?
the access layer is the layer where the end user is directly connected.
Any example? What is the end user?
End user, like suppose that in our office, like we are the end user, our laptop is directly connected to that LAN cable or
Laptop. So one example is laptop. Any other end user?
so that printer or the server
Yes.
which we are directly access.
Server, CCTV. Okay. There is a APs. These are the end devices. So first of all, you have to understand what are the end devices. So if you go and these are the end devices, see, mobile phones, laptops, servers, IP phones, CCTV. These are the end devices. So access layer is a layer where my actual end points user directly access the network. I mean the switch which is going to be connecting the network at the very last layer of the network. At this network, my end user is going to be connected. That's the meaning of the access layer. Clear? Means we have to connect our end user. Now we'll talk about more what access layer switches are going to be there, how it is going to be connected. What is a distribution layer? Distribution layer is basically help to connect my access layer and the core layer. Means it is going to be act as a man in the middle. It's going to act as the aggregation point. Means any traffic coming from the access layer, they must have to pass to the distribution layer and then it goes to the core layer. So distribution layer is going to be middle layer. Now we have to discuss why distribution layer is needed and what is the use cases. That also we'll discuss about that. Core layer. Core layer is basically a layer that is the backbone of the network. Means that is known as the backbone of network. Means this is going to provide any kind of the connectivity. Means your company want to connect with ISP. You want to connect with a multiple building. Multiple, you have the department. Then the connectivity should extend and should share through the core layer only. Means every building need to be, for this example. Let me show you. See, you have the vantage is coming here. You have the data center is coming from here. You have the internet is coming here. So everything is coming from the your core layer, and core layer is going to be, it could be your distribution layer. Might be you will get the one more design here. This one you can see here. So this is coming directly to the core layer, and core layer is further offloading the traffic to the distribution layer, and distribution layer is going to be communicate to the your end user. So in this design, if you see that, means my access layer where my end users are going to be connected. These are the access layer. These are the small switches. The small switch. Okay, these are also all a small switch. These all are going to be a small switch. But this is going to be little bit big switch. And it is also going to be more big switch. So let's suppose this is your company. Company have the multiple building. This is the building 1. This is the building 2. They have the very thousands users sitting here. Thousands users sitting here also. All 1,000 users are going to be connected with the access layer. But they need to aggregate the signals. Means whatever the traffic they have, they need to aggregate and send to the distribution layer. So they have the individual distribution layer switches. Each building they have the distribution layer switches. Further, this distribution layer switches having the uplink to the your core layer. They are not directly going to connect with the vantage data center. We can do that. But when we have the very large network, when we have the very big network, when we have the very vast network, we have to design in such way where my core is always going to be aggregation point for the multiple locations, multiple department, multiple buildings. And you can see here. So that means in this 3-tier architecture, every traffic coming from the different aggregation layer or distribution layer, they all offloading to the core, and core is further exchanging to the downstream. Any traffic coming from here, it is going on to the upstream. It's sending to the upstream that way. So the core is basically going to act as your backbone of the network. Clear? I hope this one is clear to everyone. So core is provide the connection between the distribution layer and the large environment. Now this is a simple, you can see the diagram, core, distributions, and the access layer. Now let's do the deep dive. this network can be a 2-tier architecture and can be a 3-tier architecture. So when we have to use the 2-tier architecture and when we have the 3-tier architecture, if I talk about 2-tier architecture, that means my distribution and core layer is going to be known as the one layer. Means we have the access layer where my end user is going to be connected, and instead of having the dedicated core layer, we can use the one layer that is going to act as the distribution layer and the core layer. Both layers are going to be same. And I want to scale that. This is known as 2-tier architecture. And if I want to make the scalable network, that means I need to deploy 2 more distribution layer, and then it is going to connect with the core layer. And that is going to make your large network connectivity. So the core layer, hold on, 2-tier architecture is basically also known as the collapse core. Means sometime in interview this is going to be asked, what is the collapse core? So collapse core is nothing. Collapse core is something, means your distributions and your core is going to be merged together. So why it is going to use smaller campus network, have a multiple department spread across the multiple floor within the same building. Means if you have the very small network where we have the multiple department, multiple floor, but small, not very big, not very large, not like the SCL, Wipro, Airtel, like that. So in that case, you can use the 2-tier design. And in this environment, core layer may not be needed. You can see here. And collapsing the core function into distribution means you just putting the core function distribution itself. Distributions switches are also going to be your large switches. So you can put your distribution layer, all core layer functionality on the distribution layer, that is going to act as a core of distributions. And in this case, your design is going to be like this one. See, all WAN edge, data centers, internal edge, network services, everything is going to dominating on the core layer. That is the acting my distribution as a core. That's why it's known as the collapse core. Means collapse core, we are just removing the core layer and putting everything on distributions, which is acting as my core layer. And further, we have a distribution layer going to connect with my access layer as well. And if I talk about 3-tier architecture, that means what is 3-tier architecture? 3-tier design separate the core and distribution layer. You can see, and are recommended where more than 2 pair of distributions which are required. Means when we have the more than 2 pair of distributions which is, then it is going to required. And when we are going to be implemented, means when implementing the network, large enterprise campus, you can see, composed with the multiple buildings where each building require dedicated distribution layer. Each building are going to require dedicated distribution layer. When WAN density routers, means when the density of the WAN router, internet edge devices, data center servers, and network services are growing to the point where they can affect network performance throughputs. So whenever we have the bottleneck of throughputs, when we have the growing infrastructure, very large infrastructure, complex infrastructure, dedicated bandwidth is needed, then we have to design in the 3-tier architecture. So 3-tier architecture is having a dedicated core layer, dedicated distribution layer, and you can see access layer. Similarly, you can see here also distribution, and then we have the core layer. So just aggregating everything based on your topology. Now, any question till here? Anyone have? Guys, about the core layer or distribution layer? Yes, Dinesh.
Sir, I have one question. Is there any drawbacks like merging core and distribution together?
Drawback is only if network is going to be large, right?
Okay.
The throughput is going to be a bottleneck. You have to again scale your network. Means your switches are not capable to handle very high throughput traffic. Means their capacity is going to be lower down. The moment you just increase the more distributional core layer and you try to make the 3-tier architecture, then it is going to be mitigate the problem. But this is recommended for the small network. So if you have the big network, it's never going to be recommended. So you can see the drawback is the two-tier architecture is that is only can be used for the small campus network. If campus is big and you're using the collapse core, so your traffic is not going to be properly processed. Your bottleneck is going to be happen, and your might be network is going to be like a highly latency network. Means there is a slowness it is going to be observed. Okay, Dinesh?
Okay, sir, but like for example, just the hypothetical question.
Okay.
I know like the company is small today, okay, but in near future, I know that company gonna grow and we need some more devices on that. In that perspective, is it good idea to recommend the company to go for three-tier or still we gonna go
No, no.
near to?
Initially, you can go with the two-tier only if your company is growing because you're purchasing the switches, right? These switches are going to be there, right? So this can be scale, no? That's why you can see the design. I'm trying to explain. If you let's suppose you're using this today, you have let's suppose 500 users. Take an example, and they are able to manage everything via this one. Okay, clear? Now you have the 1000 users. So definitely this is going to be your bottleneck. It's not going to be handle all the traffic, high speed bandwidth. So you can parallelly create two more distribution switch here. Okay. So they are going to segregate your 500 LAN here, 500 LAN here. Clear? And then you can just buy the two more switches and connect with the core, and then it is going to connect with the ISP. So it's going to be scalable. You can say design showing the scalable network. So if you design the two-tier, it always going to be scale. And most of the company do this kind of the enhancement, network refreshment, network upgradations by updating their hardwares. Updating not hardware, updating their designs by using the same hardware or buying some new hardware. Make sense, Dinesh, or still have the follow-up questions with you?
All good, sir. Now clear. Thank you.
Okay. Okay, now let's talk about little bit about the redundancy. Means whenever you're going to build any kind of the LAN network, how my redundancy is going to be happen? Any guess? Do you have any redundancy for the access layer?
STP, MSTP, or STP?
No, I'm not talking the protocol level, just talking about the physical hardware level.
If we put it in stack, sir, then
let's suppose these are the all individual switches, not in stack. Okay. And if I connected one of the PC here, this switch is going to be down. Then what is going to happen? Do you have any redundancy for this particular PC? What do you guys think?
Like additionally, we use access points wireless if when
Just
access.
Just focus on this connected with the wired, no wireless. If this switch is connected with this particular port, might be the gig 0x1, and this switch down, this PC can internet means they can access the internet or not?
No, it will be down.
It is not possible.
Not possible.
Down only. Down only. Because the end user device have only one Ethernet connection.
Right. So PC is having only one NIC card. Okay. And if this NIC card is connected with the only one switch, and if that particular cable is down, switch is down, this PC doesn't have any backup plan to go on the internet. So do you think this is a good design or it's a bad design? It's a good design or bad design? Or it's okay? What do you guys think?
Nowadays, most of the PC coming with wireless
line. Yeah,
transfer.
that's a wireless line. Yeah, that's definitely they're going to get a signal, but it's okay. That's fine. That much risk we can take. Why that much risk we can take? Because you're not 100 of users are impacted. Only the user are impacted which are connected on the switch. Means one switch is getting down and all end user are connected on this switch. So at this point might be this 3 or might be the 4 user who all are connected. They are going to be not able to access the internet, but remaining are still able to communicate. So initially that's not going to be critical service impact for your company point of view. It's a service impact. Switch is down, definitely you have to turn on. But what you can do that? You can move this user. You can just ask, you can connect with the cable with this particular switch. We have the available port. So easily your company have the free ports available. Let's suppose one switch having issue, some area having issue. So might be, let's suppose, think in this way. Let me draw something. Okay, hold on. What happened? Okay. So let's think about this switch is giving the connections to this users, this all 4 pieces. This is there. This is there. And let's suppose one is free here. There is another place is free that is connected here. So if this is down, this switch is down, this 4 user is impacted. So you can just simply say, can you just sit here? So they will connect the LAN cable here and they will start accessing the internet. And that's okay. That's fine. There is no problem. So always in access layer, if end switch is going to be down, any switch is going to be down, where we have the physical connectivity, that level not we have the redundancy. Make sense? Generally, we not have the redundancy in the wired connection. I'm not talking the wireless as of now. But user need to physically move the cables and they can communicate to the, means they can connect the cable with a different kind of the area or department. But when you think about this uplink is going to down, think about, or there is one user connected. Will there any impact is going to happen or not? Now the switch is up, but if this uplink is going to down, is there any impact happening or not? What do you guys think?
Yes. If it is signal
No.
unstable.
If we have a ℧ availability means it's not impact anything.
Yeah. If we have 2 links, then not an impact. But
Because
if we
the
have
access is
signal
just
link,
connected into course distribution or course
By,
layer means
by referring this topology, do you have any impact or not? Just think about the
No.
logic.
no,
no.
because
No
the other
impact.
link is
No impact. Why no impact? Still
because
has
there
the
is another
backup link.
Yes.
And it can still make the connectivity with the ISP. So no problem. So even my one link is going to down, there is no impact. I can store my configuration, troubleshooting, whatever I want to do that, and I can make this link. So that's why you can see we have the dual connectivity with my distribution switch. Why dual connectivity? And every location you can see that dual connectivity with my distribution switch. Why? Because in case of my link failure, still my users have no service impact. Any link failure is going to happen, primary is going to happen, secondary is still going to be there, and it is going to serve your all kind of the traffic, all kind of the internet connectivity. So that is known as the link level redundancy. Okay. So now we understand if this switch is going to down, then what is impact going to happen? If this link is going to down, then what is impact? If this link is also going down, then what is going to happen? This switch is going to impact or not?
Yes.
Yes,
Yes.
definitely, because no way we can make the connectivity. So if this both uplink is going to be down, then we have to be definitely service impact is going to be there and user is not able to make any kind of the connectivity, any kind of the communication to the internet. Now, same is going to be happen for this one. Same is going to be happen for this one. Same is going to be happen for this one. If both link going down, the service is going to impact. If switch is going down, then service is going to be impact. If my one link is going to down, either of the case, it's not going to be impact. But now you think about this switch is going down. What is going to happen? This switch is going to impact or not?
No.
No, because there is another
The
core
another
and-
switch core switch is there.
That another switch is still going to serve your connectivity to the internet. And if this is also going down,
Yes, site is also
Then
isolated.
it will impact.
definitely. So you guys understand why we need a 2 distribution switch here? What is the use of the 2 distribution switch and what is your 2 uplinks? Make sense? To make sure we have the high availability in the network. Initially I discussed now your network should be expandable. Your network should be scalable. your network should be highly available. And if I'm not going to use this two switch and I just make that, I just make this one switch, just one switch. And if this switch is going down, then your whole network is going to down. So the moment you're going to design network access layer, you can connect these multiple switches. There's no problem. You can connect these multiple switches individually or stack. I will discuss what is a stack also. But your distribution layer should be single switch. It should be dual switch. So if 𝗵𝗃 is going to be design the network, he must consider, even it's a small office, my access layer might be the two switch, but my uplink should be the again two switch, should just make sure they have the primary and backup kind of the redundancy. Clear? Now, we discussed about the one of the stack switch. What is a stack switch? In the LAN. It's also going to be used in the LAN, in the access layer. Anyone know what is a stack switch?
Multiple hardwares combined together and act as a single switch.
Yes. So by default, let's suppose, take an example. One switch, how many port? 24 port or 48 port, right? But if we have the requirement to get 200 ports, how we can get that? In that case, we can use the switch stacking. Switch stacking means the logically, physically, all switches are going to be like switch 1 is going to be this one, switch 1, again, then the other switch 2, third switch 3, 4. They are going to put in this format, and there are the stack cable is going to be connected. Means so these are the stack cable. These stack cable are going to be connected and they are going to make the logically one switch, but they have the multiple ports. Every port have the 48 port, let's suppose. So 48, 48, 48, 48, it's going to be almost 200 plus ports are going to be there. By using that particular port, we can make the more connectivity. So if you go here and switch that, Cisco stack switch, say image. This kind of do the stacking. You can see connect the cable from one switch to another switch, and first is going to in the last. Here I did the exactly same thing. See this particular cable. First is connected with second one, third one with the fourth one, and the first one again the last one. And they are the stack cable. They are known as the stack cable. So you have to purchase the stack cable you want to make, and your switch should be also be a stack switch. It's not like with a non-stop. So if you just search what is the stack switch, so stacking connect the multiple physical switch up to 9, means 8 or 9 you can do that maximum depending on the model, using with a specialized cable to the function as a single unified unit. Means the multiple unit are going to look like a single unit. You just have to manage with a single logical IP address. And what is going to give that? It is going to increase your port density. Means your one floor is required of 200 ports. So you might be need a 5 stack switch which have the 48 port. So they are going to be almost 200 plus ports are going to be there. So you have to do the stacking of the 5 switches. So increase the port density, and also it will increase the bandwidth and traffic processing capability. And for simplified management via the one IP address, means logically it's going to be look like a single switch. Means when you're going to log into the stack switch, it's going to look like a single switch, but you can manage that single switch via the single management IP address, but they are going to have the multiple data plane, 5 data plane with the high processing. So management of the entire stack with a single IP address. So you can just log in one switch or single IP address and do the all configuration. And there are the one master switch is going to be there that is going to active as a stack master, and then performance is going to be dedicated high. So this can be also possible you can make the stacking in the access layer. And let's suppose you have the 5 switches are in the stack. Let's suppose, take an example. These 4 switches are in the stack. So even one switch is going to down, this ports connected on this particular switch. Any device is connected on this particular switch, they are again going to be down. Because physically the cable is connected on that particular switch. So I have the 5 switch here. Understand, right? So 1, 2, 3, 4, 5. There is a PC connected on the 2 number port. And this switch is down for some reason. This physical device can be down. So the devices connected on this particular switch need to be reconnected on the other switch port. Else they will lose the internet connectivity or any kind of their LAN connectivity. Make sense, guys? You understand the stack as well?
Yes, sir.
Okay. Now, similarly, access layer is going to 2 uplink core layer, distribution layer in the 2 tier. But if you have the 3 tier, again you have the core layer, and core layer again have the dual uplink. So again, let's suppose there is one PC connected here, and tell me if this link going down from the core, any impact is going to happen or not?
No, sir.
This link going down?
Yes.
Think again.
Oh, no, there is another distribution. Yes, that should be up.
What was this? 𝗵𝗶𝗴𝗵, Vadalians, 𝗵𝗵𝗫, Shapul.
Sorry, sir, I have some internet glitch.
Okay, the question
I
is,
can't be able.
you can question it. Question is, this core layer is under distribution layer, right?
Yes.
If this 2 is going to be down, does this lose the connectivity or not?
No, sir.
No.
Because another switch is also there.
No, sir.
That
Their
particular
connectivity possible because the connectivity is going from another. There is a 2-tier system, so is going from another right side switches.
Yes, they can go still via this path. Now, if this two cable is going to down and this is also going to down, then what is going to happen? Still, this PC is able to access or not?
Can you able to access
Via this link still, right?
Yes. Yeah.
And if this is going to down, then only it is going to be down.
Down.
If this switch is going to down, then still they can access via this one. So you have the highly redundancy. Even the distribution layer level, 4 links. We have the 4 links, and here we have the, again, for the access point layer also have the 4 links. So in case of the any kind of the failures, we have the redundancy, and based on that we can reach to the any kind of the destinations. So again, access layer, that's, let me theoretically little bit read about it. Access layer is also commonly referred as a network edge layer, where the end user devices or endpoint is going to be connected. You can see these are the devices which are the representing to the access layer. Now, distribution layer, the primary function of the distribution layer to aggregate access layer switched in a given building or campus. Distribution layer provide the boundary between the layer 2 domain of the access layer. When you can see, if you have the any access layer and you want to make the boundary between the core layer, and then it is going to be your core layer. Means the access layer. Distribution layer is going to be connected to the core layer and the access layer. Now you can see these are the different building, and you want to make the connectivity. So that is going to be, and this all are going to be connected with the distribution layer, fiber optics, whatever you want to do that. And core layer is your backbone. They're just connecting to multiple distribution layer, and based on that you can design your 2-tier architecture, 3-tier architectures, right? And 2-tier architecture is also known as the collapse core. Means you not required the core layer. You can use the distribution layer and the core layer together to make the network connectivity. And also, if you want to use the 3-tier design, that is going to use this kind of. So I think you guys understand at least this concept. High availability, how it is going to happen, 2-tier and 3-tier architecture. Any doubt in 2-tier and 3-tier, access layer, core layer, and distribution layer, guys? Or we are good till here? Shall I move next? Okay.
Yeah.
Now we have to understand a fabric. What is a fabric? Anyone know? What is a fabric? Any idea what is a fabric?
Just in layman's terms, I may be wrong. Like building any infrastructure under, like we have underlay, and on top of that if we add any service or something like that,
Yeah, that's correct. Very, very close.
network, something like that.
Right. Uh, Give me 1 second. All right. So basically, the fabric is nothing. Fabric is basically, let's suppose, let me open the one of the lab. This is topology we can call as the SD-WAN fabric. Okay. If you go and just search here, I'm showing so you can have the design blueprint in your mind. This is your fabric. You can see it's fabric, SD-WAN fabric, network fabric. See? So fabric is nothing. Fabric is just connecting your underlay overlay networks together and make them able to communicate to each other. Means any communication, any transmissions, any kind of the data exchange, they want to do that. So we have the connectivity, we have the network topology, we have the physical logical connectivity, IP, transport, cable, fiber, that is going to make your fabric. So if you search in the Google also, what is the fabric, network fabric, you are going to find some good definitions as well from the network fabric layer also. So there are a lot of things available like Cisco DNA Center. If you go here, let me just explain. So if you talk about the Cisco SDA, that is the software defined access. That is having the software defined, that is a one fabric. We have the Cisco SD-WAN that also have the fabric. ACI that also have the fabric. So any traditional network like VLAN, spanning tree, manual configurations, they're just going to make the underlay, like anything you are going to make that is going to act as the underlay connectivity, and that's going to become a very complex. But when you talk the fabric is going to combination of your underlay versus overlay. So any network design, any modern network design you're talking about, any modern network design, all network design means even you're building the Cisco SD-WAN, this is going to combine your underlay plus overlay, and then they will build the SD-WAN fabric. Simple. Similarly, if you want to build the SD access network, that again required, this is the underlay plus this is going to require the overlay, and then they will build the SD access fabric. Similarly, Cisco ACI, that is going to data center. Again, it's required the underlay versus overlay, and it's going to make the fabric. So this is how your fabric is going to be look like. Means anything you want to build the fabric is just going to give the centralized control, scalable segmentation, endpoint mobility, policy-based configuration, and they use the major protocols in the to build the fabric, that is like the VXLAN. We are going to use the LIPS protocols. We are going to use the eVPNs. We are going to use the OMP, right? Like that, like a lot of things we have. So these are going to build the fabric. So here you can see a network fabric is the high speed interconnect infrastructure or hardware, switch, router, and cable. Who is going to give that? That is the, for Cisco point of view, nowadays high speed network is going to be your SD-WAN fabric. It is going to be your SD access or the data center. So a network fabric is the high speed interconnect infrastructure hardware, router, switch, cables. Software act as single and unified, often in the virtualized entity to manage network traffic. It's enable efficient, scalable any-to-any communication of the data centers. Simple, means anywhere to anywhere you want to make the communications. it is going to help you to allow that communication. It is going to be structured, performance, it's going to be automated, means you want to do automation, it's possible. Means you can easily scale the networks as well. If you want to build a fabric network, it's going to scale. So even you want to learn in the Cisco, so fabric is nothing, it's just like what is the network fabric? Network fabric is the mesh connection between the network device such as the access point, switches, router, transport. Means any topology you want to build, any design you want to build. Generally, fabric refer as the SD access, SD-WAN and ACI network. But if you want to just understand in the layman language, so fabric is nothing. Fabric is just, you can think about interconnection of the devices from, they can do the communication by using the high speed, high scalable network. That is the meaning of the fabric. Clear? Any doubt? Let me see if this book have the any. Let me, what is the fabric? Here you can just find some good examples as well in book as well. RSTP are not going to discuss. So they're talking about the SD access as well, design. Yeah, so you can see here, so fabric technology. So we are talking about the fabric. So again, software defined access, it's a part of the fabric. This section defines the SD access over traditional campus network as well the component fabric NSDN. So we'll talk about more about this, but software defined access. Software defined access means there are the traditional way, we have the 2-tier architecture, we have the 3-tier architecture, but every configuration we have to do via the manually. But the moment we are using the fabric concept, that means you are going to do the configuration via the controller. So in the SD access, we have the controller that is known as the DNA center. In SD-WAN, we have the controller that is known as the vManage. Let me show you if I can show you. Yeah, so if I want to do any kind of WAN management and I want to just do any configuration troubleshooting. So this is a fabric-based network. So I can do the device configuration, certificate, template, policy. You can see if I want to do the monitoring and everything, that is going to happen from the centralized vendor. Similarly, we have the Cisco DNS center, which are responsible to do any kind of the policy enforcement, any kind of the configuration, any kind of troubleshooting from the your any remote locations or controller based architectures. So very small topic, and but we'll discuss SDXS in very detail because we have to learn this SDXS later on. So I'll explain about the Catalyst SD-WAN solution, how it is going to look like, and also I'll explain about the SDXS in detail. But for time being, what is Fabric? Fabric is nothing. Fabric is just your any sophisticated network where underlay, overlay are going to be built together, and they're going to give the high performing network to just carry the high speed traffic and make the lot of interconnect between the cloud providers, your data centers, or other locations as well. Okay. Now, what is a cloud, guys? Anyone know what is a cloud? Any idea? What is a cloud?
So it is kind of virtual network where the devices are created and
Okay, that's
like
good. What else?
Actually, sir, cloud is a physical is a bank of server, and that is access to is a subscription based. If I talk about Azure cloud, then if I get a subscription, then I can use the monthly bill basis, and they are use I can create a VM like this, all router, load balancer as per hourly rate basic, and there I can install my all of things, and I can access inside India, and if I try to access in outside of India, then there I have to follow some network security protocol, then I can access from outside of India. So that is all about cloud.
Okay. Okay, good. Thank you, MI and Arpita. Okay. So cloud is nothing. If you talk about the cloud is basically, if you talk about the generic definition, what is a cloud? So cloud, yes, MI, please mute yourself. Cloud is your big data center. MI, can you mute yourself? It's big data center. MI, can you mute yourself? MI? So cloud is nothing, it's a big data center. Means any data center you are building, cloud is also going to be your big data center. And in this big data center, what you can do that? You can store any kind of the servers, files. You can manage servers, right? You can process data, any file, any user information. So it can be anywhere across the globe. It can be, cloud can be anywhere across the globe, and you don't have to manage this platform. It's not like it's something is moving in the air. It's not a cloud like that. Cloud is actually physical locations where we have the physical servers. So in the cloud, you are going to find a lot of big switches are going to be there. A lot of big routers are going to be there. A lot of big servers are going to be there. A lot of big kind of the load balancer is going to be there. And a lot of big, your firewall is also going to be there. So it's combination of the multiple devices. These multiple devices can be used to make the high performing network to just store any kind of the files, process those files, process those data, connect the any kind of the enterprise network from the any remote locations by minimizing the cost. That's the meaning of cloud. Means it's a big physical data center, but it's a rental based services. Means you don't have to manage their air conditions. You don't have to manage their electricity. Okay, you don't have to manage their IT engineers who can just do the iOS upgradation and software upgradation, make the connectivity. No, nothing you have to manage. You can simply take the services. Simple, how you can understand this one in better way. Like one builder is building the very big building. Let's suppose 24th floor building. Lot of flats are going to be there in this particular building. So if you are going to buy this particular flats, so you have to pay a lot of money, and also you have to do all maintenance, means everything you have to pay. But if you are going to take a rent, let's suppose I want to take a rent, so you have to pay a small amount of the money, and every services are going to be available. And whenever you feel like I'm done with my all renting work, like my job has been completed for particular Bangalore location or Delhi location, I can switch in the Kolkata. I want to switch in the Pune or might be the Mumbai. I can easily switch that. My location, I don't have to worry about sale and who is going to manage the building. So renting is simple. Data center is going to provide the space, provide the servers on the renting basis, but those are also are basically based on the hardware, based on the server. So cloud is nothing. Cloud is a big data center which is going to process your lot of traffic, but that traffic can be belong to your organizations or multiple organizations. That's why it's a shared model. So going to be always cost effective. And type of the cloud is going to be your type is going to be your private cloud, and one is the public cloud. What is the private cloud? What is the public cloud? Anyone know? Any idea? Private cloud and public cloud? Battalion, you want to say something? Battalion? So see guys, private cloud is the one cloud. Let's suppose is the private data center. Private cloud is think about the private data center. Means third party vendor is going to build a data center for you and they will rent entire data center for you. Let's suppose SCL is building the data center. And I say, no, I want my private data center. So in SCL campus, they build one of the infrastructure where the routers, servers, everything is going to install, but only for the GoINET company. They are going to store the services. So that is going to be a little bit costly, but only the one company data center data server are going to be stored. I mean, data is going to be stored. That is the private cloud. But when you talk about the public cloud is basically like you have the Azure, you have the AWS, we have the GCP. These are the public cloud. We have the Alibaba, where we have the server. In this server or my data center, multiple client data is going to be stored. Thousands of clients, 2,000 clients, 1 lakh of clients, data is going to be stored. And they all are accessing the servers. Other services are on the renting basis. This is known as the public cloud. But these are going to be very cost effective. Okay. So if you talk about anyone know what is the SaaS, what is the IaaS, and what is the PaaS in cloud?
So service as a service infrastructure and platform as a service or something.
Any example you want to give? It's a good, right? Software as services, infrastructure as services, platform as services.
I have heard, sir, but not sure.
SaaS, any example, Dinesh? SaaS, any examples? Are you using any SaaS based application right now?
No, sir. I have no idea. Just I have heard those terms while you were teaching firewall, so I heard that. So
okay, no problem. Let me explain the options. All right, so we have the cloud. Cloud can be deployed in the three parts. One is the software as services. Another is going to be a platform as a services. And another is going to infrastructure as services. And final is the on-site. So whenever you're going to deploy the any cloud-based design, any cloud-based communications, you must know about these all three terminologies. What is my software services? What is the infrastructure services and platform? So software services, you guys using the Google Drive? Are you guys using Google Drive or not?
yes.
So you guys are using the Google Drive. Google Drive is equivalent to your pen drive or not? Pen drive also what you do? You store your photograph, videos, your resume, your files. You do that, no? Google Drive also do the same thing. Do you agree with me or not?
Yes.
Yes. But pen drive you have to manage. Pen drive you have to manage means if you buying the pen drive for 16 GB or 32 GB, you always have to manage. Means if it is going to misplace, then your data is going to misplace. If it is going to be somehow damaged, you have to go and take the recovery from the any recovery centers like that. So this device is belong to you, right? And everything you are doing, first you have to purchase, then you have to manage, you have to do the maintenance, everything you have to do that. But in Google Drive, what do you need? You need just username and password. And after that, what is going to happen? By using that username and password, your credential is going to be written on the Google Drive, and you just need internet access and you can just upload the file. Nothing else, right? Your file is going to be saved. No maintenance, no hardware issue, no recovery backup, unless or until you are deleting by yourself, okay? Or you're losing the credentials. Your data is going to be saved. So software services means you sitting in the any place of your home, means any place of your home, just need the internet access. You don't have to worry, and your data or services are sitting in the cloud provider like AWS, Azure, or Google, and you have to access. Like bigger example is Google Drive, box.com, like you just accessing O365. You guys are using the email right now. Email is completely SaaS applications. It's hosted in the cloud and you just have to access by using that internet. You don't have to do anything else and it is going to be always accessible. That is your SaaS applications. Make sense? So everything means your applications, data, runtime, middleware, OS, virtualization, servers, storage, and networking. These all are going to mention by, or that is going to be managed by your cloud provider. You just have to pay the rent. You don't have to worry my OS is correctly working or not, my networking is working or not, my storage has full or it's a free. You don't have to worry about anything. Everything is going to taken care by your provider. Like labs, you guys are going to access the lab. These labs are going to be accessible from anywhere. Gwinnett Labs. These are SaaS-based applications. You don't have to worry whether the RAM has been full or the lab or not. My PC have the memory or not. No, nothing. You don't just have to need the internet access, open the labs and start doing the labs. Means whatever the lab you want to do that. Like CCNP, we want to do that labs. Anything, OSPF I want to configure, multicast I want to do that. Span, RSpan I want to do that. HSRP, VRP I want to do that. Anything I want to do that, I can just simply go and do that in the lab. There is no problem at all. So this is how we can do the all kind of the connectivity by using the SaaS application. SaaS is not required any kind of the hardware dependency, OS dependency, application dependency. Just you have to access the application. That is a SaaS. But when you go for the PaaS, platform as a services, then these RAID part is going to manage by your ISP. Means the provider. They will give the OS, networking, server, storage, everything they will give you. But you need to host your own application. Let's suppose I am the company, I want to host the 𝗲𝗏𝗃 application or Peanut Lab applications. So I will host in that location. That is known as the platform as a services. So everything is going to host at the top of this layer. So till RAID is managed by the cloud provider. And your this green or blue you can think about that is managed by you. So that is a platform. Platform in services means you just have to host the application. Let's suppose you take the infrastructure, server is ready, and you're just hosting the application, any website, any application, any kind of static server, any kind of FTP file server. Those is managed by the your platform as a services. In a infrastructure services, they will give the networking, storage, server, and virtualization, but OS you should manage, middleware you should manage, runtime you should manage, data you should manage, and the application you should manage. Based on that, you can means half of things is managed by the provider and half of things managed by you. So that is going to be 50 or 60% like effort is going to be required with the your providers and also from the customers. So they can host their application, data, and runtime everything. So that is going to be dependency for the infrastructure services. But when you go for the on-site, means on-prem data center, in that case, you have to manage everything. Your location would be your office should be yours, your electricity would be there, your routers should be there, your network should be there, your storage should be there, your engineer should be there. So your data center you're going to manage. Means everything. So it's going to be very costly. It's going to be very cost effective. Not cost effective. These are the cost effective. Lowest cost is going to be in the SaaS application. But every SaaS application is not available in the cloud. Okay. Sometime customer need to deploy their services in infrastructure services, sometime platform services. And most time, if you want to build everything by your own, then you have to build your own data center. So in your own data center, your location should be your building should be your electricity should be there, your cabling should be there, networking should be there, router, switch, everything should be there. That is how going to be your cloud. Any questions regarding this cloud? How cloud is going to look like? Any doubt regarding these all infrastructure services, performance services, and the software services? Or we are good?
Sir, I have one doubt. You mentioned like types of cloud, private and public. So on private cloud, who manage that cost and everything? Is it still like the company who owns it, or is it still the cloud provider?
See, so private cloud, what is going to happen? Let's suppose private cloud like SCL is going to be private cloud, cloud providers. Like Rackspace is going to be private cloud providers. So they will give the space for you. Let's suppose they have the data centers in New Jersey, Rackspace or SCL. So if you want to host your services there, so they will give a dedicated space for you, or might be they will give a dedicated server to you. Okay. In that servers, you can host your all kind of the routers, switches, firewalls, servers, everything. So your server is going to be dedicated to you. No other vendor is going to be access those server. Only you can access, but that is not your infrastructure. That is their infrastructure. You paying rent for that server. That is a private cloud. So if you go here and discuss the private cloud versus public cloud. So large enterprise, high security, like banking, stable workload. So see, public cloud, as I mentioned that Azure, AWS, pay-as-you-go, highly scalable, third-party hosted, rapid grow, while private cloud provider dedicated on-prem infrastructure for the maximum security, control, and compliances. So private cloud providers, if you see that, providers. In private cloud providers, you have the AWS, Outpost, Microsoft Azure Stack, Google Distributed Cloud, and also we have the HP Green, we have IBM, we have Nutanix, we have Dell Technology, we have Oracle, have Rackspace, a lot of company, SCL also, Wipro also giving that private cloud. Private cloud is just giving the space to you, and you manage everything on that particular space. Think about, I can give one of the laptop. You just want to purchase one of the laptop, so I can give the one of the laptop to you, and you paying for that particular laptop. But what you doing that laptop, you just known by you only. I mean, what OS you hosting on that laptop, how many file you hosting. So that is dedicated to you. But if this laptop is going to access the 5 users, means 5 users can work on different time, then it's going to be public laptop, shared laptop, and the cost is also going to be lower. But dedicated is going to be higher, but it's a higher security than this. Okay, makes sense?
Yes, sir.
Okay, any other questions, guys?
No, sir.
Okay, so I believe we are good for today. And there are a lot of theory, so I don't want to speak next 30 minutes more. So we'll go slowly in theory part. So let's connect tomorrow and we'll continue from here. All right, makes sense, everyone? Is it fine?
So what will be timing for tomorrow classes?
So, ma'am, timing would be the same. This session is going to be reserved for 10 a.m. IST to 12:30 p.m. IST. This is the time reserved, but we will try to finish 10 to 12. Okay. Sometime if needed, we'll extend this, but we'll try to take at least 2 hours session on the Saturday, Sunday.
Okay, sir.
All right, everyone. So tomorrow we'll do a little bit chit chat. We'll have the introduction and all, and then we'll continue the FHRP, SSO, and other topic discussion, SD1 and all. Okay. Thank you, everyone. See you in the next class. Bye bye. Take care.